welcome to 8-16. On our today's lesson, I'm going to explain how we are going to find the stationary point or points of the mathematical expression in general. So, in order to find the stationary point for this problem, first of all, you have to understand what is the stationary point for a function in general. A stationary point for the function is always obtained when we are finding the zero of the first derivative for the function. Is that so? The stationary point of this problem means that it is given by dy by dx, which is gonna be 0. Is that so? In order to find the stationary point for this problem, at the very beginning we need to find the derivative of the given function. Is that of the given expression? Then what will be the derivative of this problem? Since it is a polynomial function, the derivative for this problem is gonna be done this way. So when you find the derivative for this problem, it is going to be what's the derivative of the first term. So to find the derivative of the first term for this algebraic expression, now you have to bring the exponent as a coefficient, and that is gonna be 4x raised 4 minus 1, that is 3, minus 2 times, you have to bring 3 back, 2 times 3, x raised 3 minus 1 will be 2 plus 2x plus 0, because the derivative for any constant is going to be 0. So when we are really interested to find the stationary point or points of any function, as I have already said before, now it is simply the stationary point to mean it is simply the 0 for the derivative of the given problem. So I have found the derivative for this function, and you have to equate this, which is going to be 0. Is that so? You have to make just like this one. And then what we're going to do now, let's take out the common problem for this. That is 4x cubed minus 6x squared plus 2x is gonna be 0. Is that? And then take out which is common. 2x is common. Now when we take out 2x from every terms of this algebraic expression, and that is gonna be 2x squared minus 3x plus 1, which is going to be 0. And then when we say the product of two numbers or two algebraic expression is gonna be 0. For example, when we say a times b is going to be 0. Now a times b will be 0 if either a, which is 0, or either b, which is 0. This is the way how to find. Is that so? Based on this principle, now this means that what this means, 2x should be 0, or 2x squared minus 3x plus 1 is gonna be 0. And then when we come to the final case, when we are solving this one, x is gonna be 0, and or 2x squared minus 3x plus 1 will be 0. Then we have to just solve this problem. One stationary point is 0, and the other stationary point must be obtained from this one. And hence, let's solve this one. 2x squared minus 3x plus 1, that's gonna be 0. To find the zeros of this problem, or in order to solve this quadratic equation, let's find two numbers whose sum is perfectly minus 3 and whose product is gonna be AC, that is 2. So what are the numbers? The numbers are automatically what? The numbers is gonna be this mean numbers p and q will be minus 1 and minus 2. That means if you add both, that's minus 3. If you multiply them, that will be this one. And hence this can be factorized as, this can be written as x minus 1 into x minus 2. That's going to be 0. But since the coefficient of the leading term for this problem is gonna be 2, so we have to divide these 2 for this one and this one, and which implies that x minus 1 over 2 into x minus 2 over 2 mean that's 1, which is going to be 0. And hence this implies that x will be 1 over 2, or x will be 1. So from previous procedure, we always have x value 0, and therefore generally the stationary points are what? Therefore the stationary points of these are what? Stationary points of these are x is equal to 0, x is equal to 1, and x is equal to 1 over 2. So these are the stationary point for this function. So in order to determine generally the ordered pairs of the stationary, now when we are plugging 0 here, we can have 6. That's very simple. When we are plugging 1, we can have some value, and when we plug 1 over 2, we can have another value. So we have selection a stationary point for this polynomial function. So this is all about our today's lesson. If you are a new member of my YouTube channel, don't forget to share, like, and subscribe. 8 Thomas 16. Thank you for